So, good morning, dear friends. Today we have discussed the design of flat slab. What are the different elements and how to design the pre-stressed concrete flat slab. In RCC also, flat slab is there. Now the syllabus is Introduction to the flat slab, design of pre-stressed two-way flat slab by the direct design method. There are two methods. Out of two methods, we have used only direct design method, which is given in IS code. So begin with, these are the textbook which is generally used for the pre-stressed concrete structure. Design of pre-stressed concrete structure by T.Y. Lin. Father of, we can say that, the pre-stressing. Pre-stressed concrete second book, which is very good from the our university syllabus point of view. That is the N. Krishna Raju Tata McGraw Hill publications. Also, apart from that, we have also used some other reference books. That is the Fundamental Approach by Edward Navy, that is pre-stressed concrete. Reinforced concrete, design concrete by Pillai and Menon, that is also one of the best book. And we have used the IS code, IS 456, which is used for the RCC design. For some clauses also, we have referred this IS 456 for the design of pre-stressing. And second, IS 1343 2012. This is the revised IS code. Indian Code of Practice for pre-stressed concrete, BIS, Bureau of Indian Standard, New Delhi. Now, when we consider the slab, in case of RCC, we know that the classification is either one-way slab or two-way slab. In one way, we have considered the simply supported, continue or cantilever. In case of two-way, it depends on the aspect ratio, or we can say that the ratio of longer side to the shorter side. If it is less than 2, then we can design the two-way slab. It is greater than 2, then we go for the one-way slab. Similarly, for the design of two-way slab, all 4 supports are needed. Even sometimes if the ratio is say 1, for example 3 meter by 3 meter slab is there, 4 slab is there, but there is no beam on the one side. 3 side beam is there, one side there is no beam. Then even though the ratio is satisfied, but we can design as a one-way slab. So what is the difference between the pre-stressed concrete slab and the RCC slab? The basic difference is that in case of the pre-stressed concrete slab, we have provided the tendons. And the high strength concrete is used. But in case of the RCC, we have provided the reinforcement, that is the steel, along X direction, along Y direction in case of two-way slab. So in pre-stress, one-way slab is there, design of one-way slab, design of two-way slab is also there. That is a rectangular slab panel supported on all the 4 edges by either wall or beam. And third is the flat slab. Generally, in case of RCC, flat slab is also there, and in pre-stressing, we have used the flat slab. Flat slab means the slab without beam, or we can say that the slab which is directly rest on the column, that is called as the flat slab. Now there are 4 conditions in case of the pre-stressing. Flat slab without drop and the column head. That means the slab directly rests on the column. This is the first case. Continuous slab of constant thickness supported by rectangular grid of the column. There are number of columns. Second, flat slab without drop but with column head. There is no drop. We will discuss in the next slide what is meant by drop and the head. But without the column head, only drop is there. Third one, flat slab with drop and without column head. Drop is there but column head is not there. And last, flat slab with drop and the column head, both are there. That means that if the span increases, then we can provide the last version. That means this is first one. For the small slab, if you increase the span, we have used the case number B, C and D. So these are the some figures which show the this is one-way slab. These are the columns and these are the beams. One-way slab is there. Two-way slab is also there. Here two-way slab is there. 2-way slab depending on the ratio. These are the beams. That means that there is a beam are there on all the four sides. All four supports are there. That's why it is called as the 2-way slab. This is the column and this is the column position. And the here in case of the flat slab, there is no, we can say that the beam, but there is a distribution similar to RCC 2-way slab. We have provided the A strip, middle strip and A strip like that. This is the middle strip, this is the A strip, this is the A strip, and this is the position of the column. So we have discussed in detail in the cross section. Now this is the typical details of the flat ducted tendon. That means the when we apply the pre-stressing, the such type of, we can say that the tendons are provided. This is the cable 1, cable 2, cable 3, cable 3 like that. This distance is 19 mm and this distance is 75. This total cross section of the, this is the cross section of the duct which is provided here, 1, 2, 3, 4 like that. And this is the, these are the, we can see that the cables. These 4 cables are pressed in the we can say that the at the ends of the slab with the help of such type of arrangement. We can use like this or also like this. We can separate it all these 4 and all these 4 will be stretched with the help of hydraulic jack. And these ends are, this is the toward the slab and this is the external side of the slab. This will be stretched with the help of plate. Now this is the cable profile. As we know that bending moment is negative at the mid span, and that's why to resist the bending moment we have provided the sag like this. At the simple support, bending moment is 0. That's why we can provide the cable at eccentricity 0. Here it is maximum at the support. This is of course it is parabolic, and if this support is continued, in that case we can provide the cable, because there is a negative bending moment. Here there is a positive bending moment, and we know that tension will be developed at the top, and to resist that tension we can provide the cable profile like this. This is the eccentricity which is above the neutral axis. Here this is the eccentricity which is below the neutral axis to resist the positive bending moment, and this is to resist the negative bending moment. This is the cable profile, and this is, we can say that just mirror image of the bending moment diagram. Okay, this is the idealized, and actually we cannot provide like this because it is a parabolic, and that's why in the actual provision, actual implementation of the cable, we can provide like this. This is not at the point, but this is the this is the point of contraflexure, we can say that. Then it will be shifted like this. This is the actual cable profile in the beam as well as in case of the, we can say that the slab. Now what are the design steps? Design of flat slab, we use the direct method. We can refer both the IS code IS 456 as well as IS 1343. Now what is the data required? Now in this case we require the size of the panel, position of the column, that is L1 and L2, that is the longer span and shorter span like this. WL is the external load, FP is the trace in the tendon or pre-stressing wire, and FCK is the characteristic strength of the concrete. Now what are the requirements? First is the thickness of the slab, and second is the eccentricity. Third one, size of the drop, capital and column head, we can find out. Number of cable profile in the middle strip as well as in the column strip or A strip. This is the requirements. So step number 1, first of all we can find out the width of the column as per IS 456 2000 clause number 31.11 page number 53. That means similar to the RCC slab, similar to the RCC flat slab, we have designed the up to the bending moment, we have designed the pre-stressed concrete slab. So width of the column strip is equal to width of the column strip, that is equal to 0.25 L1, or we can say that L by 4, L1 by 4 or L2 by 4, that is the LX and L1, longer span and shorter span, whichever is less. That means we have considered the out of this whatever the less distance is there, that gives the width of the column strip. Total width of the column strip, that is equal to, from this is from the center, and that's why total width is equal to 2 times of the width of the column strip. This is the total width of the column strip, 2 times of BC. Similarly, width of the middle strip along the longer span, this is related with the column strip, and remaining in the middle portion we have considered middle strip, that is L1 minus 2 times of BC and L2 minus 2 times of BC along the x direction, along the y direction, that is the longer span and the shorter span. This is the middle strip. Then step number 2, thickness of the slab. Again we use the reference of IS code IS 456, clause number 31.2.1, page number 53. If the drop is not provided, if there is no drop, what is drop, that will be discussed in the next slide. If drop is not provided, then we have considered the depth, that is the thickness of the slab is equal to Ly. Remember, this is not Lx, that is the longer span divided by 32 into 0.9, and this value should be greater than or equal to 125. That means the minimum thickness of the flat slab is 125 mm. If drop is provided, then you can take Ly divided by 32, eliminate this 0.9. This is also greater than 125 mm. This is the thickness of the flat slab. Now, here in IS 456 2000, these figures are given. This portion is called as the drop. This portion is called as the drop, and this portion, that is just attached to the slab, thickness is greater here. This portion total portion is thicker than the actual thickness of the slab, that is called as the column drop. This portion is column, and how to find out this, it is given in IS code IS 456 2000. This angle is 90 degree, this angle is 90 degree. That means how to provide the column head and the capital. These are the certain guidelines given in IS 456 2000. This distance is d by 2. What is d? D is the effective depth here. So during the design, we have discussed these points in detail. Step number 3, size of the drop. Again we use the IS 456 2000, page number 53, clause number 31.2.1. Size of the drop is equal to L1 by 3 by L2 by 3. That means the square. For the interior panel, similarly drop for the external or outside or toward the edge of the slab, we have provided 50% of this. L1 by 3, L2 by 3, 50% of this. Similarly, the thickness of the drop is equal to 1/4 of D. The drop which is closer to the slab, next to the slab, near the column, 1/4 of the D. That is, D is the thickness of the slab, 25%. Then size of the column head or capital. Column head or capital is related with the above the column or below the slab or drop. Then diameter of the column head is equal to 1/4 of L to 1/5 of the L, where L is the average span length. That means there are two span, L1 is there and L2 is there. We can take the average. We get the size of the column head or capital. Similarly, load on the slab. Load on the slab, we have considered the dead load, that is equal to density of the, see, listen here, it is not RCC slab, it is a pre-stressed slab. That's why we have considered the density of the plain concrete, that is 25 multiplied by thickness of the slab. Floor finish load, we have assumed here the floor finish load is generally considered less up to 0.5 kilonewton per cubic meter, and the live load generally given. So we get the total load, and once we get total load, we know that design load in case of limit state method, we can apply the partial safety factor. So 1.5 times the total load, that gives the design load. This is the step number 5. So remaining steps we will discuss in the next lecture. Thank you very much.